Hello, today we're going to be talking about whether a function is odd or even again, but this time we're going to determine it algebraically. We're going to start off with 8 functions. We're going to graph them using a graphing aid, mainly Desmos, and then we're going to look and say, are they odd or even graphically? If you haven't seen the video already on how to determine whether a function is odd or even using their graphs, please go back and view that. Now, once we determine that, we're going to look at some patterns and see if we can figure out a way to determine whether a function is odd, even, or neither with some algebra. Okay? So let's look at the assignment I've got listed there for you. It looks something like this. And I give you an example. Ignore the directions right here for a moment. What I first want you to do is open up Desmos, and I want you to go through and graph each of these 8 functions, just the ones that are listed there. So once you've done that, you should have something that kind of looks like what I've got here. Now I've gone through and I've just highlighted the function that we're graphing down below. Okay? And I want to go through and say, are these odd, are they even, or are they neither? So for this first one right here, remember, graphically speaking, if it's symmetrical over the y-axis, if we can fold it on that y-axis there, then it's an even function. If we can take and spin it 180 degrees and it looks exactly the same or symmetrical about the origin, we say that it's an odd function. And if we can't do either, we say it's neither odd nor even. So obviously if we fold this on the y-axis, this space is going to end up over here and it's not going to match up. But if we take the graph and we spin it 180 degrees or turn it upside down, it matches up perfectly. It looks exactly the same. So this one is an odd function. Now we're going to go through all 8 and just determine whether they're odd, even, or neither first, and then we're going to do the rest of this work up here with each function. So this next one, graphed, should look like this. Obviously, if we turn it upside down, it's not going to match up. But if we fold it along the y-axis, we see that it is symmetrical there. So it's going to fold up and match up perfectly. So this function is an even function. All right, let's try out number 3 here. Number 3 isn't going to be even. Obviously, it doesn't fold there, but it does look to be odd. Let's look at it. Spin it 180 degrees upside down, and notice it matches up perfectly. So this is an odd function. Next one. Now, here we have a quadratic, but unfortunately it's been shifted to the right and down some. And now when we fold it in half, on the y-axis that is, it doesn't match up perfectly. So it's not even, and if we turn it 180 degrees like this, we can see it's not going to be odd either. This is going to be a neither. All right, let's move over to the back of this thing. Look at number 5. So in number 5, if we take and turn this 180 degrees, it doesn't match up. And obviously this one is not symmetrical at all. If we fold it on the y-axis, it's not going to match up that way either. So this is a neither also. Look at number 6. Number 6, you fold it on the y-axis, it's not going to match up. But if we turn it 180 degrees like this, notice it does match up perfectly. This one is an odd function. Number 7. 7 looks to be odd. Let's look at it here. Spin it 180 degrees. Matches up perfectly. It's an odd function. And then number 8 looks to be even. If we fold it on the y-axis, looks like a bird, doesn't it? It matches up perfectly. So that's even. So as we look at this, it's pretty easy, once you get the hang of it, looking at graphs and determine whether it's odd, even, or neither. But it's not always a good case where we're not in a situation where we can graph something and check for it's odd, even, or neither there. So we need an algebraic approach. So I'm giving you a couple of hints here dealing with these negatives. And what I want you to do is go through and find the f of negative x, and then find the negative f of x. Although those look the same, they can be different. So let's see exactly what I want here. This one, it goes by pretty fast. If we put negative x in for x, we get negative x. And if we multiply the original function by a -1, we get negative x. So that one doesn't really clarify what I mean to do with all this. But if we look at number 2, let's work through number 2 together. It's saying that the h of x is equal to x to the 6 minus 2x squared plus 3. Let's first find the h of negative x. Now remember what we did with this. We said everywhere we see an x, we're going to put a set of parentheses. And then I'm going to substitute negative x in for x there. Now, any negative number raised to an even exponent is going to give me a positive. So negative x raised to the 6 gives me positive x to the 6. And then negative x squared just gives me positive x squared. So I end up with minus 2 times x squared. And then plus 3 right here. So this is my h of negative x. The next thing on that third line, I want you to find the negative h of x. Now how is that different? The negative h of x is simply going through and multiplying each one of the terms on h of x by -1. Or you could say it's flipping the sign there. So x to the 6 becomes negative x to the 6. Negative 2x squared becomes positive 2x squared. And then positive 3 becomes negative 3. And so this is the negative h of x. So I've got that written out on this sheet, and I actually need to go back and change this because I notice I've got a positive 3 there. That should be a negative 3. So if you saw that in the video a second ago, I'll have that updated on the handout or the answer key. So anyway, we've got the negative h of x, we've got the h of negative x, and we've got the h of x. Those three should be listed out just like I have with number 1. I want you to go through and complete the rest of these. And I'm going to do it here in a second, but pause it and see if you can go ahead and get number 3 done. All right, hopefully you had a chance to go through and at least try number 3. I went ahead and summed up these two that we did on the first couple of ones, and I want to go ahead and make a note here of whether we mark these functions as odd, even, or neither. So this first one right here on number 1, we've written it off as odd, and we determined that graphically. So I'm just going to write odd right here. And then the second one, we said graphically that this is an even function. And so we're going to go through and do this with each one of these coming up, all 8 of them, and see if there's a pattern going on with here that can help us determine the difference between odd, even, or neither. So let's look at number 3 and work through it. So here we want the g of negative x. So I'm going to write out this function, and everywhere I see an x, I put a set of parentheses. And then I substitute negative x in for it. And this is going to give me negative x cubed plus 5x. That is the g of negative x. And then if I take the negative g of x, well, multiply that by negative, multiply that by negative, and the negative g of x gives me this right here. Now, we said that this function was odd. And because I'm showing my work here, just so I can kind of see things a little bit better, let me just highlight these. Those are the 3 that you should have written out. All right, let's look at number 4. So number 4, we've got the f of x is x squared minus 2x minus 3. We're going to take the f of negative x. Remember, we put a parentheses everywhere we see an x, and then substitute negative x in for it. This gives me x squared plus 2x minus 3. That is the f of negative x. And then the negative f of x, remember, is just taking the f of x and flipping all the signs there. So I get negative x squared plus 2x plus 3. So here are the 3 that you should have written on your worksheet. And for number 4, we said, number 4 was what? We said it was neither. All right, let's look at number 5. Number 5, the h of negative x. Everywhere I see an x, put a set of parentheses, and then substitute negative x in. And I like to just write it without the parentheses. If there's nothing else I can simplify, so I get negative x square root negative x plus 5. The negative h of x, remember we're multiplying each term by a negative x. So right here it's just one term. It's x times square root of x plus 5. So we're going to say this is negative x square root x plus 5, like that. And looking at number 5, we said number 5 was a neither. And if we highlight it, these are the 3 functions you should have written out on your paper. All right, number 6. So the g of negative x, everywhere I see an x, put a set of parentheses, and then substitute negative x in. Negative x cubed, because it's raised to an odd exponent, remember it's like saying negative x times negative x times negative x. These two multiply to give you a positive x, but multiply it by that third one there gives you a negative number. So it's going to be negative x cubed minus 1. That is the g of negative x. If I take the negative g of x, it's multiplying each one of these terms by a negative 1. And I get negative x cubed plus 1. So looking at these right here, I've got this one, and this one. All right. Number 7. All right, everywhere I see an x, I'm going to put a set of parentheses. I'm going to substitute negative x in. This gives me negative x, and then 1. This becomes negative x squared. It becomes a positive x squared, but I'm subtracting it like that. And so this is f of negative x. And then the negative f of x equals, multiply each one of these by a negative. I get this right here. All right, we said number 7 was an odd function. All right, one more here with me. Remember, I'm doing this so you get some practice too with this functional notation. And so don't think I'm just giving you a bunch of busy work. We're getting used to how we can use function notation to substitute these in, especially when we don't have just a number to put in. We're using variables, and sometimes this itself can be challenging, so I want to give you some practice with it, especially that negative x there. So if we put in h of negative x, we get the cubic root of negative x quantity squared, which becomes the cubic root of positive x squared. And then the negative h of x becomes, well, just multiply that term by a negative. You get negative cubic root of x squared there. So these are the three that should be written on your paper. The original, h of negative x, and the negative h of x. And we said this function was even. All right. Now, going through all these, as we were working them, I realized I made a mistake. And maybe you caught it a moment ago. Maybe you didn't. So if we go back and look at number 6. Number 6, I didn't write it down because I knew when I did number 6 a second ago, just by looking at these algebraically, that I made a mistake when we did it graphically. Let me see if I can pull up number 6 on my little cutouts here. Let's see, where did you go, number 6? Here it is. This was number 6's graph right here. We said this was an odd function. And you know, we all make mistakes. I made one, and I hate making a mistake when I'm teaching, but I also like it. I like it because I want students to know that even a teacher has his days where he makes mistakes. You know, I make mistakes every day. I try to make as few mistakes as I can when I'm teaching math because I don't want my students to repeat those mistakes, but learn from mine. So on this one, I said it was odd, and maybe you caught it when we were going over it, and you said, oh, that doesn't make any sense, you know. Let's look at this, and it's real easy sometimes when it comes that close to the origin to mess it up. Our origin is right here on both of these graphs. So notice this is the original when I flip it this way. And so this function, I should have noticed it algebraically, it got shifted down 1 unit. So it shifted down 1 unit here and here. When I spin this 180 degrees this way, notice this way it's shifted up a unit. And so these are not exactly the same. I thought they were when I was first looking at it. It's just my mistake, but when I was looking at it algebraically later on, I noticed like, whoops, that's not an odd function. So it's not odd, it's not even. This is going to be a neither here. So correct that, make that a neither. Now, that will help you because otherwise it might have confused you when we went to look for patterns here. I want you to go through and look at all of these. And we've got them now listed as odd, even, or neither on all of them. And see if there's something in common with the odd ones. See if there's something in common with the neither ones. See if there's something in common with the even ones. So pause the video, look through those, and see if you can come up with a way algebraically to tell if a function is odd, even, or neither. All right, I'm about to give you a big hint. So maybe you paused the video, maybe you didn't. But let me give you this big hint on just determine whether a function is odd, even, or neither. Let's look through and see which of these are the same. Well, these two right here are. So in this case, the f of negative x and the negative x are the same. And we got the function was odd. Let's go to the next one. Are any of these the same? Well, that one's got a minus, plus, plus, minus, minus. These two are the same. And we said the function was even. All right, let's look at number 3. So number 3, we said it was odd. Notice that these two right here are the same. Go back and look at the odd function over here from number 1. Okay, let's keep it going. Number 4. Number 4, we said it was neither. Well, these two aren't the same. Let's look at these two. These aren't the same because of the plus here and the minus up there. None of them are the same. So none are the same. And we got neither there. All right, I'm going to put this in the neither pile, see if the neithers have that pattern there. By the way, notice my nice little artwork here? That's just my scrap paper because these Sharpies bleed through the paper. But it is very artistic, I feel like. All right. This one we said neither again. Let's see if any of them are the same. Well, that's a positive x. These two are negative. But then when I get in here, that's a negative x, and this one's a positive. So none are the same. And we got neither there. Number 6 was a neither. That was that one I messed up on, I think. And so looking at this, this one is not the same as this one, and this one's not the same as this one. So none are the same. That's how I knew from the get-go, like, wait a minute. If none are the same, why did I say one, you know, it was like odd or even, whatever I put it as. Number 7, this one's odd. Let's see if we got some that are the same here. That's a positive x, that one's a negative, so those two aren't the same. But these two bottom ones here, they are exactly the same. So, and we got that one to be odd. And then lastly, number 8, we said it was even. Notice the even ones, the bottom two are not the same, but the top two are. So this one is the same as this one right here. All right. Now take a look through them, match up your even ones, your odd ones. I'll go ahead and do that now, but you can pause the video if you want to try it out. I know a lot of students want to determine this stuff on their own. Here's an odd function, bottom two are the same. Number 3, an odd function, bottom two are the same. Number 1, odd function, bottom two are the same. Look through your even ones. Number 2 is an even one, top two are the same. Number 8's an even one, top two are the same. So in general, we can say this, that if, notice the top two, we've got the h of x, if it's equal to the h of negative x, then we can say function is even. All right, and then when the bottom two are the same, if the negative h of x equals the h of negative x, we can say that the function is odd. And so really, you know, and then of course we can say that if none of them are equal, then the function is neither. Really, it all depends on what is equal to the I can't talk today, the h or the f of negative x, whatever you're calling the function. So if the h of negative x equals the original function, it's even. And if it equals the negative 1 times the original function, it's odd. All right, and this is kind of makes sense if we talk about y equals x squared. If we go back to that function, think about what it looks like. It's a parabola, right? And so it doesn't matter if we're looking at it chart-wise here. If we put in 3 into this function, we get 9 as our value. If we put in negative 3, we get 9 as our value. If we put in 5, we get 25. If we put in negative 5, we get 25. It doesn't matter if we put in a positive or a negative, we get the same y value. So we say that function is even. And then likewise with x cubed. If we have y equals x cubed, it looks like this. And if you make another chart for it, if you put in 3, you get 27. If you put in negative 3, you get negative 27. And so the h of x is equal to the, or the h of negative x equals the negative h of x. I think it's easier to see it written out than saying it like that. But if we put in 3 and then multiply it by negative 1, we would get the same thing that we've got right down here. Negative 3 equals negative 27. Okay? So algebraically speaking, this sums it up right here. That's how we determine whether a function is odd, even, or neither algebraically. All right? So if you have questions, let me know, and I'll be happy to go through some things with you there. You're going to get a little bit of practice on going through this. The main thing is putting in that negative value in. So if you're taking the function as f of x, take in the f of negative x and see if does it match the original function or does it match the original function times a negative 1. All right? If you have any questions, let me know. I'll be happy to answer those, and thanks for watching.